This video is about motion, chapter motion, and I have done 3 questions, one from NCRT book and 2 from exemplar. This is a numerical problem based on chapter motion in physics. These questions are important questions. I hope you will enjoy it. So you go through them, watch them. Thank you. This is a question of physics, chapter is motion. A ball is gently dropped from a height of 20 meter. Okay, this is a height, this is the ground, this is the ground. Okay, and this is the height. How much is this height is? This is 20 meter. This is the height. Here the ball is at here and this is the ground. Okay, it is. Velocity increases uniformly at the rate of 10 meter per second square. Okay, the acceleration of the ball is 10 meter per second square. Now the question is, with what velocity will it strike the ground? Now here the u is 0. Okay, you have to find the v. V is how much? At what velocity the ball is strike the ground, and after what time will it strike the ground? You have to find two things here. Now the times, time the velocity, the ball touching the ground. So this is we have to so solution is like this. Yeah, answer you can write here now. That here u is equal to 0. Okay, and s is for height, it is 20 meter, and g is given here. G is given here now. G is downward way. This is positive. G is positive here, 10 meter per second square. You have to find time to reach the ground and the velocity at which the ball strikes the ground. So we have to use one Newton's equation. So this is a velocity position equation. It is here now. We have v square is equal to e square plus 2as. Okay, this velocity position equation, v square is equal to u square plus 2as, right? Here v you have to find, and the u is how much here? U is 0 plus 2 into a is 10 here, and the height is 20. Okay, so that comes to be v square is equal to how much? This is 400. Therefore v is equal to under root 400. Therefore we get now v is equal to 20 meter per second. 20 meter per second is here. Yes, the velocity at which the ball will strike the ground is 20 meter per second. Next we have to find the time. Okay, now the velocity time equation is this: v is equal to u plus at. Okay, again now to find the time, use this velocity time equation. So V is just now you have got 20, U is 0, A is 10 here, and the T we have to find. Okay, T we have to find. So that implies now, so 20 is equal to 10T, and that implies T is equal to 20 by 10 is equal to 2. Now 2 seconds. So we got both the answers. T is 2 seconds, and the velocity at which the ball will strike the ground is 20 meters per second. It's okay. So the answers you can collect anywhere. So V is equal to 20 meters. It is 20 meters per second, and T is equal to 2 seconds. So this is the answer. This is the answer. We must have to collect the answer at the end. This is important. Right now. So answer is V is equal to 20 meters per second and T is equal to 2 seconds it is. So this is the answer, we got it. Okay, this is the answer. This is the answer it is. This is a question of physics. A motorcyclist drives from A to B with a uniform speed of 30 km per hour and returns back with a speed of 20 km per hour. So, okay, find its average speed. So this is this. Suppose this is a point A and the point B. This is point A and the B. Okay, it goes with a speed of 30 km per hour. It's okay, and comes. Okay, returns with a speed of 20 meters per hour. It's okay. Find its average speed. So, in order to find the average speed, we have to find how much time is taken going from A to B and how much time taken to return from B to A. The distance A and B is not given. So let the distance be x kilometer, because the distance is x kilometers, right? The distance is x kilometer. Now to find the time is equal to distance by speed. So time taken in going from A to B. So time taken now, right now. So time taken in going from A to B is equal to how much? So let it be, it is T1. T1 is equal to how much? It is x by 30. Okay, that is hour. It's okay. You can let here that let AB is equal to x kilometer. AB, the distance from A to B is x kilometer. Therefore, the time taken in going from A to B is x by 30. Now, time taken in returning from B to A is how much here? Look at the distance is same, x, but here the speed is 20, so that much hour. Okay, clear? And total time taken is how much here? So total time taken is taken t is equal to t1 plus t2. Okay, and that is equal to x by 30 plus x by 20. Okay, the LCM will be how much here? The LCM will be 60, and this will be now this 2 plus 3, 2x plus 3x, so that is equal to 5x by 60. So okay, this is the time taken. Now total distance, how much it is? The total distance. So total distance is equal to x plus x, isn't it here? Okay, x is from going A to B, and this x is for returning B to A. So this is 2x. Now the average speed. Average speed is equal to how much? So total distance. Total distance by total time. So that is equal to total distance is 2x, and the total time is 5x by 60. So 5x and 60 will go up. This will get cancelled, and 5 with this one. Okay, so it is 24 kilometers per hour. This is the answer. And the average speed is 24 kilometers per hour. This is the answer. Okay? This is the average speed. Average speed is 24 kilometers per hour. It is. Okay. Now the question is, a girl walks along a state. A girl walks along a state path to drop a letter in the letter box and comes back to its initial position. Her displacement time graph is shown here. This is shown here. Plot a velocity time graph for the same. This I have plotted. It is here now. Here. The girl is starting from here. Okay, and goes to 100 meter in time 50 seconds. The girl cover 100 meter in 50 seconds. This is time axis, and this is distance axis. So how much is the velocity? Velocity is 100 by 50, that is 2 meter per second. So, okay, now let us find the velocity. Show the velocity answer. Velocity show as per displacement, time graph the velocity of the girl is 100. Girl is equal to 100, right here now, is equal to 100 meter by 50 seconds. Okay, it is come to be 2 meters per second. You know, the girl starts from here, origin, covers a distance of 100 meter. This is meter. Okay, in 50 seconds. And the important thing about this is that in next 50 seconds returns to its initial position. Here, this is the initial position. He returns to his initial position. Okay. So the time taken to return is same as the time taken to go to drop the letter. So here the velocity is constant. Okay. Now the velocity is constant. Now this is velocity time graph. This is velocity time graph. This is x-axis. So this is velocity time graph. Now symmetry of displacement time graph shows that now symmetry of this is symmetrical it is, symmetrical it is here. It takes 50 seconds to go 100 meters and takes 50 seconds to come to its original point. Therefore symmetry of displacement time graph, displacement time graph shows that the girl returns to her initial position, returns to her initial position with the same velocity. Okay. But in opposite direction. In opposite direction. Okay. Therefore this is the velocity time graph is drawn here. This is the velocity time graph. It comes in the opposite direction. Therefore this is the velocity time graph drawn. Okay, this is